Hello friends, welcome back to another interesting video on my channel of Debneel's Mathematics Desk. And probably the part I was waiting for has come today on this chapter, coordinate geometry. So in the previous video, ending part, I told you that how we can mix linear equations and graphs of coordinate geometry together. That's going to be a mystery. Let's now unfold this mystery in front of the screen. So before unfolding this mystery, a huge thanks to all of you for showing your lovable support to my channel till now. I expect you to show your love and support to my channel if you are finding my videos very important and helpful and attractive as well. So keep doing that. It motivates me to make better videos for you all each and every day with a higher energy and higher quality. So let's move on with the new concept of today. So you know linear equations. No introduction to that. What are they? Like this. Suppose x plus y equal to 6. This is a linear equation. How can you represent this equation through a graph? Suppose if I take x equal to minus 1, then what will be my y? Then put it here. Therefore, y equal to, so from this I can write that y equal to 6 minus x, right? 6 minus minus 1, 6 plus 1 equal to 7. If x equal to minus 1, therefore y equal to 7. Similarly, if I put x equal to 0, therefore y equal to 6 minus 0 equal to 6. If I put x equal to 1, then y equal to 6 minus 1 equal to 5. So by putting three values of x, we get respective three values of y. Now what do we know? What are the forms of coordinate? X, y. So here I have three pairs of x and y. There are three coordinates which are what? Minus 1, 7, 0, 6, 1, 5. Why x is written first? You always know x is the axis side is written first, then the ordinate y. You know that. So these 3 points. Now you will find that when you plot these 3 points on a graph and join the line, that is the graph of the linear equation. This is how easy it is. You take 3 values for x, one at a time. The values should always be minus 1, 0 and 1. And corresponding value of y you will get the 3 pairs you will get for x and y, 3 coordinates. Okay, plot those coordinates on a graph. Then if you join the line of those points, that is your graph for the linear equation. Means the equation will change as we keep changing the values of x. But suppose this kind of equations are there, x equal to 3. Then, and 3 cases need to be there. Then here in both the all the cases x will be 3. No situation of y is coming here. Now you will change the values of y. So as x is constant, we take 3 different values of y. 3 cases. Now the 3 coordinates are what? At a time. 3 minus 1, 3, 0, 3, 1. And actually mistakenly I wrote the question of the first question. But I have not drawn the graph. Now if you just plot these 3 points on the graph paper and join them, that is your, means joined by straight line obviously. And mostly I think that all these points are always collinear. We learned what is collinear, all the points lie in a straight line. So that straight line between the points is the graph actually. So that's the basic concept that you just saw here. Now no more explanations. You are eager for the sums, I can understand that. Let's see what can be there from this exercise. So just remember the values of x will remain changing unless and until y, means suppose y is not there, then we take different values for y. And suppose if y is only there, means no case of x, then we take 3 different values of x. That's how it to adjust. That's the main point. So the heading is for today, draw a graph. For here is your first question. So x minus 5 equal to 0. Now what can I do? I can modify this equation as x equal to 5. Then take 2 columns x, y, and 3 cases. So what do I see here? X is remaining constant. No case of y is there. So in 3 cases x will be 5. Now as y is not there, we have to take 3 values of y, which should always be -1, 0 and 1. Then xy pair at a time, we have got 3 coordinates, therefore points equal to what? First one is what? xy 5 -1. Next one is xy 5 0. Next one is xy 5 1. These are the points. Now draw the graph. So let's draw the graph here. Come on, I am now learning to draw good straight lines. I told you I'm bad at drawing. Hey, I can improve. So let's draw the whatever may be the coordinates, something like this. And for here -1, -2, -3, -4, -5, -6. Let it be up to here. -1, -2, -3, -4, -5, -6. Let it be. So first coordinate 5 comma -1. Plot it. 5 units on x-axis here. -1 units on y-axis, that is here. So these two will intersect somewhere around here. So this is the point. 5 comma -1. Got one out of the way. 5 comma 0. 5 units on x-axis here. 0 units on y-axis here. So these 2 points will obviously intersect here. Okay. So 5 comma 0. So this is 5 comma 0 now. 5 -1. Where are they intersecting? Just checking something, guys. Just give me some time. No, it has to be 5 units on x-axis. Can't do anything. Yeah, yeah. Okay. Then comes 5 comma 1. 5 units on x-axis here and 1 unit on y-axis here. See the sign and you can just see the sign and plot it, right? So these two now will intersect here, here. So 5 comma 1 is which one is which point, you might not get it. So I'm trying to make it clear. Just give me some time. Yeah, now it's okay. 5 comma -1, 5 comma 0, 5 comma 1 and plot it. Now join these 3 points. Actually it's a straight line. I may have mistaken it somewhere. Yeah. See here it should be just somewhere here. So now if you rub it again, drawing needs to be good. And yeah. So straight line. Just see the 3 points. I told you they are collinear. So when you plot the 3 points and join them, this straight line representing the 3 points. Now extend it a bit on both the edges. This straight line is the graph for the equation x minus 5 equal to 0. What we did? X minus 5 equal to 0, so x will equal to 5. Take 3 cases, x will always remain 5 because y is not there. As y is not there, we take 3 different values for y. -1, 0 and 1. Then at a time, 3 pairs, 5 -1, 5 0 and 5 1 are coming. 3 coordinates. Plot them on the graph. Join the line between the points. It is, I told you, a collinear. The points are, and that line is the graph between for this equation. Simple. Just be careful with the mark means what do I say? Creation of the coordinates, and you are the boss here. Let's see next one. Now suppose y is there and x is missing. What are we going to do? Let's see. So another equation for you. Y plus 6 equal to 0. So what can I do here? I can either modify it or y equal to -6. Yeah, I shift it to that side. Now again take 2 places, x and y. So now y is here always minus 6. So y will always be minus 6 because no x is there here in the equation. See, now we take three different values for x because x is not there, which are minus 1, 0, 1. This dot is nothing. Now what are the points at the time x, y for the foot points or coordinates, whatever you can, equal to. First one is minus 1 comma minus 6. Yeah. Next one is 0 comma minus 6. And the last one is 1 comma minus 6. X, Y, X, Y, X, Y, X, Y. Just like that. So you got the coordinates now. Now make the graph. A pretty strategic, easy method to just solve the questions. See how easy it is. And no means difficult. You have to just make the equation. If you take one value for x, obviously we will find out y. Find out y. Just that is the way to do it. Trying to draw the graph. Give me some time. I hate the minus sign. And here comes the minus on this side. Yeah, looks good. So the graph is this. Now mark it. Minus 1, minus 6 means minus 1 units on x-axis somewhere here. Minus 6 units on y-axis somewhere here. These two friends seem to be intersecting here. So this point is minus 1 comma minus 6. Got it? Then comes 0 comma minus 6. So 0 units on x-axis here. Minus 6 units on y-axis here. So this point is 0 comma minus 6. Then comes 1 comma minus 6. 1 unit on x-axis here. Minus 6 units on y-axis here. So they seem to be intersecting this point. This is 1 comma minus 6. Now join the 3 points here. That line which you can see here, I just remove this a little bit and make it down here and just mark it straight. These are the 3 points. And that's the graph. That line which passes to these 3 points is a graph for the equation y plus 6 equal to 0. Simple stuff again. Y equal to minus 6 you can get from the equation. Now x is there, right? So y will remain constant in the 3 cases. Then take 3 values for x. Minus 1, 0, 1. They should always be. Then at a time minus 1, minus 6, 0, comma minus 6, 1, comma minus 6 are the 3 coordinates. Then plot them on the graph. If you join the 3 coordinate points, you get a straight line, a collinear line passing to the 3 points. And that's the graph. The line is the graph for this equation. Easy. Now there can be situations where nothing is missing. Both x and y are there. And that's actually a typical sum. Let's see what can that be. It's raining here. And unfortunately, my fans are not working. Hence, the electrician has been called, but unfortunately he's going to come tomorrow. I am out of fans today and it's quite hot here, not going to lie. So let's see, we can concentrate on the maths to distract ourselves. Y equal to 3x. Something very nice here. So y equal to 3x. Let's directly means do xy and here no one is missing. So here what will we do? If we take the value of x as minus 1, what will be y? 3 into minus 1 which is minus 3. If we take x as 0, what will be y? 3 into 0 equal to 0. If we take x as 1, what will be y? 3 into 1 equal to 3. That's how you do it. See? Then you got the 3 points. The points are what? Minus 1 comma minus 3, 0 comma 0, 1 comma 3. A very good question. Origin is means there. 0, comma 0 is the origin. So plot the graph. What a very nice line I have drawn. I'm going to draw a small and cute graph. What is cute in graphs? You might be saying. Origin here. 1, 2, 3, 4. 1, 2, 3, 4. Got rubbed out. -1, -2, -3, -4, -1, -2, -3, -4. So let this be the graph. Okay. Too much less space for the poor little minus. Let it be like that. So let's plot -1, -3. -1 units on x-axis and -3 units on y-axis. So here, these two intersect here. So this is -1, -3. Then comes 0, 0 origin. Here 1, 3. 1 unit on x-axis here. 3 units on y-axis here. These two intersect at this position. 1, 3. Now join these three coordinate points that we just marked. Let's join them by means of a straight line, which I don't know how to draw ever. Oh, come on. Yeah, I can. I know how to draw. Just trying to increase it a little bit, then marking the points. So this line, which you see between the points -1, -3, 0, 0 and 1, 3, collinear line is the graph for the equation y equal to 3x. Unlike the previous questions, here y and x both are there. So what you have to do, take one at a time. If you take x as -1, see always the imaginary values we are taking for any one of the variables, those are -1, 0 and 1. Nothing else than that. If you take one of them as -1, 0, 1, you get the respective other values for y as well. And those respective pairs xy are the coordinates to be pointed, plotted, and the plotted points are then joined by a line. That is the graph. So no explanations needed, I think, for after that. Easy, simple stuff. Let's move on. Let's see a typical quadratic equation. Not yet. Coming is on the way. 4x minus y equal to 0. What can I do is I can simplify this equation. 4x equal to shift y to that side y. Okay. Now let's get going. X and y, I take it. Easy, 3 cases. So if I take x as -1, what will y be? 4 into -1 equal to -4. If I take x as 0, y will be 4 into 0 equal to 0. If I take x as 1, y will be 4 into 1 equal to 4. Therefore the points are what? See the equation only. 4 into -1, -4. 4 into 0, 4, 0. 4 into 1, 4, value of y. Points are what? xy -1, -4. Then another xy 0, 0. Another xy 1, 4. Something like the previous question. Now let's plot draw the graph. Drawing a smaller graph this time. It will take less time for me. Origin 1, 2. See, I'm sweating bad here. Hopefully God brings an electrician tomorrow. Nothing else I'm praying for right now. Survival is the most necessary thing. Let's get going. The graph is done here. The graph is drawn. -1, -4 first of all. -1 units on x-axis here. -4 units on y-axis here. So these two seem to be intersecting somewhere here quite nicely. -1, -4. This is the point. Watch. 0, 0 next. So origin. And then comes 1, 4. So 1 unit on x-axis, 4 units on y-axis. Intersect them, you will get it somewhere here. 1 comma 4. Join the 3 points now, easy stuff. Come on, I will draw a straight line. I fail always miserably, as you know. Oh, I think I drew it. Yes. If you draw on a graph, the means normal graphs, you get a clear straight line, not like my one. Means easily you can say annual line, means drawing going like a snake, like that. No, but still you can understand the thing. 3 points are there, -1, -4, 0, 0, 1 comma 4. Plot them, you join them, that's a straight line. This line is the graph. Again, what's the difficulty? 4x minus y equal to 0, which is 4x equal to y. Take 3 values for x, you will get the respective values of y, x, y at a time and the 3 coordinates. Plot them on the graph, join them by the straight line. That line is the graph. Easy. Actually, these type of questions come, and today it's the beginning of graphs. So don't expect that these are going to be the same. The next video we are going to get insane with these sums. Insane kind of sums. Typical quadratic equation is on your screen now. Now let's do it. This is a good question. Y equal to 2x plus 3, but not going to means good do anything to us. Take x and y, 3 cases to be filed. How do you file cases in maths? By plotting x, y. So let's take x as -1. So if you do that, you get y equal to 2 into -1 plus 3. Right? -2 plus 3 equal to 1. If you take x equal to 0, you get y equal to 2 into 0 plus 3, which is 3. So y 3. If you take x equal to 1, you get y equal to 2 into 1 plus 3, which is equal to 5. So these are the values. Now the coordinates, therefore points are, what are they? One is -1 comma 1, next is 0 comma 3, which is 1 comma 5. You want to see my face, how it's sweating? See it. I'm miserably hot now. Means what is the temperature? I'm now thinking 30, 40. It might be like that. People living in near the sea, you are having a good time than us. Okay. So let's do it here. So these are the 3 points, x, y. I take it one at a time. Now the graph. Need to be careful with this graph. Can get me disturbed. The line went very nicely. But you need to be careful, I mess up. Okay, the origin looks good. 1, 2, 3, 4, 5. Not going beyond 5. 1, 2. My hand pains when I do that. Let it be here. Here is also -1, -2, -3, 4, -5, -1, -2, 3, +4, -5. That's the graph. Now the points. -1, 1. So -1 units on x-axis, 1 unit on y-axis here. So these two seem to be intersecting quite beautifully around here. That is the point. -1, 1. Then is 0, 3. 0 units on x-axis, 3 units on y-axis. So this is this point here. This is 0, 3. They are intersecting here, obviously. Then comes 1, 5. 1 unit on x-axis, 5 unit on y-axis. They seem to be intersecting here. This is 1, 5. Join the points here. Nicely done. Kind of collinear. Actually, it's collinear. It is here actually. Yeah, see, I just go a little bit on the left side. Yeah, now it's okay. Somewhat a straight line, something might be wrong. I'm seeing properly 0, yeah, 1, -1, 1 unit. Yeah, it's okay. So just going like this. If it goes here, yeah. Alright. So see here, measurements might go slightly A to B, but if you go on the graph, it's very clear, very good clear city, that place. Here I am assuming the measurements for the respective points and trying to be accurate. You get a straight line actually, passing to the points -1, 1, 0, 3, 1, 5. And that straight line which you see here, that's the graph for the equation y equal to 2x plus 3. Be clever, take one value at a time for x. The respective value of y will get xy pair are three, for means three pairs are the three coordinates. Then plot them on the graph, same matter. Join the points. That line, the beautiful line, is the answer of this question, the graph. Let's see what can the last question of today be for us. So today actually it's an introduction to construction of graph for coordinate geometry. Gonna come very handy in the next video and the video after the next video. I wrote the last question for today now. Let's see this. Okay. So I'm going to be a little bit clever here. Then what is 3y? Here I can write 3y will be equal to 2x minus 4. Yeah. Or I can write that y equal to 2x minus 4 by 3. Bring it on. Now take x and y. You learn about dependent and independent variables, right? Means here, see, y is dependent on x. Whatever the value of x we take, the value of y becomes something for that. So we are taking the values of x here as -1, 0, 1 and get the values of y. That is our main purpose. Drawing the table so that you can understand properly, although no meaning is there. Now let's take x as -1. Therefore we get y equal to 2 into -1 minus 4 by 3 equal to -6 by 3 equal to -2. There you go. So -2 here. Then let's take y equal to x equal to 0. If I take y equal to 2 into 0 minus 4 by 3 equal to -4 by 3. Damn, that's a really confusing point. -4 by 3. Then comes, if I take x equal to 1, y will be 2 into 1 minus 4 by 3. To -2 by 3. What are not these things now, you'll be saying? Can coordinates be fractions? Why not? Let's calm down a little bit. Let's take the xy pairs. We have got the values of, if we take x as -1, we get y -2. X as 0, we get -4 by 3y. X as 1, if we take, we get y equal to -2 by 3. Okay, we have no problems with fractions. Let it be just like that. Now what are the points? xy at a time, -1, -2. Then comes 0, -4 by 3, which I am very concerned about. Then is 1, -2 by 3. You will see, you have to be clever. Okay. Remember, -4 by 3 is what? -1 whole 1 by 3. I'm coming to that. So the graph. Oh, the line went all very wrong. That's what I don't like. When my drawing goes wrong, I lose my temper. Need to get a drawing tuition. What do you say? So let's see this. Okay, why am I wasting my time? I'm going to plot the graph here. You need to be very wise here. Means it is not about that means very hard or something. It's about understanding how you can means plot the fraction. I accept coordinates can be fractions. See how. First point -1, 2, no problems. -1 units on x-axis, -2 units on y-axis. They intersect here. This is -1, -2. Then is the next problem. 0, -4 by 3. 0 units on x-axis here. But minus 4 by 3 means what? Minus 1 whole 1 by 3. So this is minus 1 on x-axis. If I take this as minus 1 means what? Minus 3 by 3. So suppose this is minus 4 by 3, minus 5 by 3. Then this is what? Minus 2. Minus 6 by 3 is what? Minus 2. Then again, minus 7 by 3, minus 8 by 3. Minus 9 by 3 is minus 3. Already there. Again, minus 10 by 3, minus 11 by 3. Minus 4 means minus 12 by 3. That's how it works. So minus 4 by 3 is what? Minus 1 whole 1 by 3. So here. Now, these 2 points, 0 and minus 4 by 3, intersecting here. This is 0 comma minus 4 by 3. Got out of the way. The problem is gone. See, I told you, just need to be wise. Then comes the next one. Next person. 1 comma minus 2 by 3. Come on, let's see this. So 1 unit on x-axis first of all. Then minus 2 by 3 means if it's starting from 0, you can take it as 0 by 3. Then minus 1 by 3. Here suppose minus 2 by 3. Then minus 1 is what? Minus 3 by 3. So this point here, this is minus 2 by 3. Now these 2 points are intersecting here. This is 0 comma, 1 comma minus 2 by 3. Get it? Now join the points. Have you drawn a straighter line than this? Tell me. I have not drawn. I have drawn a perfect line here. This is the answer. So you can take subdivisions just means wise. Here they are means just giving natural numbers or real numbers. Real numbers, integers actually. But that doesn't mean that it can't be converted to fraction. I can tell that minus 1 is minus 3 by 3. Then minus 4 by 3 is what? Minus 1 whole 1 by 3. Which is what? Minus 1, then another unit. Sub-unit. You have to take the subunits carefully. Whenever it's 4 by 3, it is minus 1 plus 1 by 3. Another subunit. If it's minus 2 by 3, it is 0 by 3, which is 0. Minus 1 by 3, next subunit. Then the next subunit, minus 2 by 3. That point. You can mark all of them as subdivisions, just like here, see. Suppose 0, 1 by 3, 2 by 3, 3 by 3 is 1. 4 by 3, 5 by 3, 6 by 3 is 2. 7 by 3, 8 by 3, 3 by 3, 9 by 3 is 3. 10 by 3, 11 by 3, 12 by 3 is 4. 13 by 3, 14 by 3, 15 by 3 is 5. So that's how the divisions are marked. You take the denominator as 3. And that's how you mark them. I can do for everyone. You see. 1 by 3, 2 by 3, 3 by 3, 1. 4 by 3, 5 by 3, 6 by 3, 2. 7 by 3, 8 by 3, 9 by 3, 3. 10 by 3, 11 by 3. 12 by 3 is 4. And marked again. Here 0, minus 1 by 3, minus 2 by 3, minus 3 by 3 is minus 1. Minus 4 by 3, minus 5 by 3. Minus 6 by 3 is minus 2. Minus 7 by 3, minus 8 by 3. Minus 9 by 3 is minus 3. Minus 10 by 3, minus 11 by 3. Minus 12 by 3 is minus 4. See, I have marked all the subdivisions now. Now you can just do it then. Just plot 3 points here. Join them. You'll get a super straight line. The best straight line I drew in this video. I'm proud of that. Because I hate drawing and can't draw properly. I'm accepting it. But I accept another thing that we have completed this part 3 quite nicely for coordinate geometry. It went absolutely according to my plans. I am able to explain you what is the concept and I hope that you understood it. You take the values of x at a time, one at a time. Then you get the values of y from the equation. If only x is there, y is not there in the equation. Y has a fixed value, x has a fixed value suppose in the equation. Means it can't change. Then let that value of x be repeated 3 times and take y's value as 3 imaginary values minus 1, 0, 1. But suppose in an equation if only y is there, x is missing and that value of y is only constant like this, y equal to 6. X is not there. So y will be 6 in 3 of the cases. Take 3 imaginary values for x then. Minus 1, 0 and 1. It will not matter because x is not there in the equation. We are just taking y. We want to frame the coordinates. And while framing the coordinates, the imaginary values always need to be minus 1, 0 and 1. in either of the cases, x or y. It doesn't matter. And then if you find the coordinates, plot them on the graph. Draw the straight line between 3 points. You will always get a straight line, and that straight line is actually the graph for the given equation. This is all about graphs for coordinate geometry. The first part actually of graphs is done. Many things are left in the next video. So I hope you understand this concept, because roots need to be hard so that the tree can grow nicely. Remember that. So then that's the end of part 3 for coordinate geometry for class 9. I hope you have understood the initial concepts of plotting of points, framing of coordinate points from an equation, and how we can just draw them on a graph and draw the straight line between them. The straight line depicting the graph or the curve for the equation. So understand that. See you in the next video with a lot more enhanced and critical sums on this topic only. It's gonna be super interesting. Till then, with a lot of love from my side to all of my little brothers and sisters. Take care and goodbye. Thank you.